Joakim Byström. I'm the CEO here at Absolicon, and I've always been interested in solar thermal energy since I was a kid. And I was first involved in my father's company selling small portable sawmills around the world. But about 20 years ago, myself and a number of friends here locally and some environment and technology colleagues I had around in Sweden, we started a project to make solar concentrators. And we had from the beginning in Absolicon this view that concentrated solar energy is a part of the solution of the world's energy problem. And the first barrier that we entered was to have money to do this R&D work. We were able to get some funds from the Swedish Energy Agency and some other independent financing sources, and we also sold solar collectors quite simply and easily in the beginning. But then we found the business angels that financed us, and after a number of years we also entered the Swedish stock exchange that allowed us to raise money from shareholders and finance Absolicon. And using this money we've been able to develop the solar concentrators and to deploy them around the world in pilot installations and other demonstrations of how this technology, large scale, can be used for industrial heat. But another big challenge was, of course, to make a product that was outstanding. And this concentrating technology has been around for many, many years. But what we found was that the performance of the solar concentrators were not as high as it could be. The optics of the concentrators didn't manage to make all the light hit the receiver in the center. So we started a journey to improve this optical performance. And after a number of years, we managed to get the highest ever measured optical performance of a small parabolic trough with 76.4% optical efficiency of aperture area. So I would say these were the two barriers that we were fighting with: the financing of the development and the actual results to get the best solar concentrator in the world. The next thing that we did when we had this product and the patents was that we developed a robotized production line that can mass produce the parabolic troughs so that we can establish mass production locally in different countries around the world where the industries are going to decarbonize their CO2. Well, the potential of large-scale deployment of small parabolic troughs, we listen a lot to International Energy Agency and to IRENA. And IRENA has in their zero CO2 pathway that in 2030 the industry should have installed 1,200 million square meters of solar thermal systems similar to ours in industries around the world. And this is necessary because the industry is a huge emitter of CO2. And if we take that as an example, the textile industry, to make 1 kilo of textile, like a pair of jeans, for example, the textile industry has emission of the corresponding amount of 2 kilos of coal. So you can say that 2 kilos of coal is burned for every 1 kilo of textile. And 8% of the global CO2 emission comes from the textile industry. But this is the same if we come to food and beverage or chemical industry or petrochemical industry or mining, that enormous amount of fossil fuel is burnt to produce heat up to 160 degrees in their processes. So this is the market that we aim for, and we have started with the food and beverage industry, where we work with different multinationals like Pepsi, Carlsberg, the Japanese company Asahi, to show them how solar concentrators can replace the burning of fossil fuel in their industry. And the volumes that we see in different countries, that is what motivates us to offer the market a robotic production line. Because without local mass production of solar concentrators, it's difficult to see how the industry quick enough can turn from burning fossil fuel to have renewable energy. And we see that many of those multinationals that we work with, they have very aggressive targets to decarbonize before 2030. And it is difficult to see how any technology can be deployed in such scale and quick enough to manage those goals. But Absolicon has a plan. We can install local robotized production lines that mass produce the solar concentrators for those industries. That actually makes it possible for them to fulfill their targets to 2030. Another market for us is the district heating sector. In Europe, there are 6,000 district heating networks, and the majority of them are burning fossil fuel to produce hot water to homes and apartment buildings. And they also have committed to decarbonize. And solar district heating is one of the obvious ways to reduce the CO2 emissions from district heating. And with the technology now where we can store the heat from summer to winter, we can easily have 50% solar thermal in many of Europe's district heating networks. And traditional flat plate connectors are good for single houses and temperatures up to 80-90 degrees. But when you look at many of the district heating networks, they require temperatures where solar concentrators is a better technology. So we see that beside the industrial market, solar district heating is also a huge market that also need to have local robotized production lines that mass produce the collectors. And we can have an example with the Finnish capital Helsinki. Helsinki every year burns 500,000 tons of coal to provide hot water to their inhabitants. And those 500,000 tons of coal, they can be replaced with 20 million square meters of parabolic troughs. So to make those 20 million square meters, the best thing is to set up a local production line that produces in Helsinki the solar collectors that Helsinki is needing. What we have worked with a lot is to be able to provide solar fields that produce heat and steam to the customer. And there we feel that we have already developed technical concept and technical product that give the performance that is needed for the industry and for district heating. What we are now developing are more methods to integrate the solar thermal into different processes. And it's a surprisingly large task to find good integration points and good way to replace the fossil steam and heat that they're using in the industry. So our new product that we are working with now are mainly soft products where we sell consultancy service in the form of concept studies and feasibility studies to help the industries to find solutions for the decarbonization. So the solar field is quite easy. We build a large field with solar concentrators, but the demanding part is the integration. And here we see also a partnership with other manufacturers of equipment for renewable heat, like heat pump manufacturers and e-boiler manufacturers and biofuel boilers that need to be integrated also in the factory for the factory to reach zero CO2. So here we reach out to a number of those manufacturers of other energy equipment. But we have also launched a cooperation with Tetra Pak, that is a multinational company selling equipment for the food and beverage industry with pasteurizers and package equipment. And there our concept is that Tetra Pak will sell their equipment powered with solar heat. So next to the pasteurizer, we build a solar field. So part of the heat comes from the fossil fuel that they're already using in the factory, and part of the heat is coming from the solar concentrators. And we see this kind of partnership when we work together with Tetra Pak as one of the key ways of actually entering into the industry. Then we also work with partners around the world who actually operate our production lines. So Absolicon key business is to sell the robotized production line to a local production line partner who then set up the plant, produce the collectors and sell them to the industry. So we are a company really working in those strong partnerships between different actors. Well, there are many who want to involve in solar thermal business out of some idea of a new product, that they want to do a new solar concentrator or a new flat plate collector. But I would say that the technology is quite mature, and that is not where the challenges are. if you want to get involved in solar thermal, the challenge is the integration into the industries and the partnership with the industry and the district heating networks. There are plenty of companies that can deliver the solar collectors and the solar collector field, but there are very few who actually know how to integrate this energy to the applications and to get a good financial solution on the whole package. And I think that is where you should focus, how to communicate with the customers, how to find financial solutions, how to integrate the heat into different processes. And if you want to produce a new solar concentrator, Absolicon is here to sell robotized production lines. We have a ready product with the highest optical efficiency in the world. It has solar key mark. We have a supply line for all the material that makes a very low cost on the finished product. And you can buy the complete package, turnkey, at 4 million euro, where we set up the production line and we train you and we get everything on site. And from payment, we have 9 months delivery of the complete system. So focus on finding customers and finding the solutions for thermal integration and not on technology.